Hello everyone. In this video, we will continue to examine topic 2, mechanics, and in particular, topic 2.1, and we will continue to unpack the concept of acceleration. So, acceleration can be a really tricky concept. And one of the important things to be able to do is to sort of visually recognize graphs and associate those graphs with each other for constantly accelerated motion. So we're dealing with constant accelerations here. And in particular, it's important to be able to recognize cases where the position time, velocity time, and acceleration time graph line up with each other. All right. So let's take a look at a classic case of acceleration, that is one of positive acceleration speeding up. So in this case, we have an initial velocity of 0, an initial position of 0. And what we can see is with a constant positive acceleration, the acceleration time graph is flat here. But the velocity time graph involves increasing velocity over that time interval delta t. Okay, so the velocity is increasing over that time interval delta t and increasing in the positive direction. The slope of this graph corresponds to the value attained by the acceleration along this graph. And if the velocity is increasing, that means the slope of the position time graph is going to increase. So you can see that a tangent line drawn at different points to this curve will slowly be increasing in slope. But let's take a look at a couple of other examples. So what does a case of positive acceleration but slowing down look like? Right? Well, you say, I didn't know that positive acceleration could involve slowing down. And the key to having a positive acceleration when you're slowing down is to start out moving in the negative direction. That is to start out with a negative velocity here. So if we start with a negative velocity and have that velocity increase in, sorry, I should be careful about this. The velocity is going to decrease in magnitude, all right, and get more positive. So for example, this might be negative 4 meters per second, negative 3 meters per second, negative 2 meters per second, negative 1 meters per second, 0, right? You can see the object is slowing down in the negative direction. Notice that the slope of the velocity time graph is the acceleration. So this is a positive acceleration because the acceleration is the slope of that velocity time graph. But also what is happening is that the object is slowing down, moving in the negative direction. So the speed is highest here. Notice that is the most negative velocity. And then it's slowly shallowing out, okay, until that velocity becomes basically 0 right at the end point in this particular example, okay? All right, well, what about negative acceleration and slowing down? Well, that is possible, all right? You just have to start out moving in the positive direction. So if your initial velocity is positive, you're moving in the positive direction on the position time graph, you're moving this way, okay? But your velocity is decreasing, then it means that speed is also decreasing here, okay? And so the slope of this graph is getting shallower and shallower. And the value on your velocity time graph is getting closer and closer to that horizontal t-axis. Notice that the negative acceleration shown here is the slope of that velocity time graph. So this is a case of negative acceleration. The slope of the velocity time graph is negative, okay, is negative. And then finally, what about a case of negative acceleration where you're speeding up? Well, for negative acceleration speeding up, we want to make sure that we are moving in the negative direction. So if I start out at a 0 velocity here, then my velocity is going to get more and more negative, okay? For example, negative 1 meters per second, negative 2, negative 3, negative 4, negative 5 meters per second, okay? Moving very fast at the end, but with a negative acceleration. That acceleration is negative. The slope of this line is negative. And therefore the constant value shown on the acceleration time graph is negative. Notice that this also involves sort of a downwards curve, right? The speed on this graph is flat at first, right? Very close to 0, and then it gets more and more negative as time goes on, okay? So big picture, pulling apart the difference between negative acceleration, okay, and slowing down, which mean different things, is really, really important. Slowing down means that your velocity is getting closer to the t-axis. Notice the velocity gets closer to the t-axis in both of those cases. Your position time graph gets flatter and flatter. That's what slowing down means ultimately. Negative acceleration, on the other hand, means that the acceleration is below the t-axis, and therefore the slope of that velocity time graph is negative. But you cannot tell that you have a negative acceleration. Sorry, I should be careful about this. What a negative acceleration means for a position time graph is just that it's going to curve as if it's going downward. So you can see that you could have a constant negative acceleration here that sort of you slowed down at first, slowed down, and eventually came to a stop and then kept going. All right, so if this velocity time graph kept going through that t-axis, you could maintain a negative acceleration while slowing down in the positive direction and then speeding up in the negative direction. So negative acceleration means whether the slope of the velocity time graph and therefore the acceleration is negative. Slowing down means that the speed is decreasing. So the velocity time graph is getting closer to that t-axis. This is distinguished in sort of great detail in this particular slide. And it's important to recognize what the difference is between these particular concepts. So these particular statements are just summaries of the descriptions I just gave.